How do you spell it? Oh my god.
It sounds interesting.
There we go. So we are doing comets today,
Whoa, really?
as I did not say before. So, comets.
This is what I'm going to try.
So yeah, go ahead and write down the second bullet point. As you're writing down the second bullet point, I'll hand out the material for this section. There are handouts for just about each thing that we cover. Remind me why it's important to keep these handouts.
Because it could be on the test.
Because of the final, absolutely. The final is only based on the information on these handouts. More on that as the final gets closer.
I have a question.
Yeah.
Do seniors get exempt?
Yeah, if you've meet all the requirements, yep.
What is the requirement?
I can throw these away.
90% or better in the class, cumulative of, what, 3.0 and higher?
That's not a question.
I think that's the one.
I got a 1.
Now, when you look at this this picture here, it's like an etching or a carving or something. And in our lifetimes, we haven't really seen a really cool comet. I actually have, because in '97 there was one that flew by that we'll learn about in just a little while. But we have never, not even me, have seen one that takes up like the entire sky like this. Comets in the past have looked like this occasionally, and this is one of Halley's comet that was drawn around the time of the Renaissance, as you can tell by everybody's dress right there. So from this slide, write down Oort cloud. Yeah. And write down the first bullet point. I actually never looked up the pronunciation. Maybe it's Oort cloud. So the Oort cloud is not something that's actually ever been observed. They just believe that all these bodies lie beyond the orbit of Pluto. So it's a hypothetical thing. It's not something we've ever actually documented or seen. It's important to mention that. So if this is our solar system, and you back out of our solar system exponentially, it goes way, way out into space. Because it's not like it's just this far away from the solar system. This is 10 to the second times that distance, 10 to the third, 10 to the fourth, and so on. So it's a long ways out there, they postulate. So from this slide, go ahead and write down the third bullet point, and that should be everything you need.
Like return or
starting with these and then the sub point there too. Yeah. Bottom two lines. So there's two different kinds of comets, and based on the path that we see them take as they get closer to the sun and then further away, we can tell how long they've been traveling and what their overall path looks like when they get far away from the sun. Because comets, unlike Earth and the other planets, don't orbit in a circle. If the sun... wonder if I can draw this so they can see it at home. If the sun is, we'll say that the sun is right here. Earth and the other planets go around in a circle. Comets go around the sun and they look something like this. So yeah, it's a very, very elliptical orbit. And one of the things we talk about in physics is how the speed changes when you do this path. Basically, when comets get really close to the sun, they speed up really, really fast. And they slow down the further away they get. But yeah, that's the path they take. We can figure that path out based on the mathematics that they can calculate when they see how the comet's actually traveling. Kuiper belt, write that down. And you can write down the first bullet point as well. Yep, just the first bullet point. You don't need to write down the hash mark underneath it. You can skip that. Unlike the Oort cloud, the Kuiper belt has actually been observed. So this is something that's been documented, and that's what this graph behind represents. It shows the locations of some of these objects. So it's between 30 astronomical units and 50 astronomical units away from the sun. Anybody remember what an astronomical unit means? Oh. Yeah, the distance from the Earth to the sun, yep. So they are between 30 Earth-Sun distances away and 50. One thing you'll see later is Pluto's average distance is about 30 astronomical units. So it starts right about in that location. And there's just a little picture of the Kuiper belt. Pluto kind of goes through it. This is one of the reasons Pluto is not considered a planet, because instead of just having a planet be something that's big and circular, they say that a planet has to clear out all of the stuff in its orbit. So clearly, because the Kuiper belt's there, and Pluto's going through it, it hasn't cleared it all out. Therefore, Pluto is disqualified as being a planet. Kind of lame to me. I don't think so. When we visit Pluto, you'll be surprised at how amazing Pluto is. Totally not a slacker. And there it is right there. You can see it's going through the Kuiper belt. And for a period of time, actually, Pluto is closer to the sun than Neptune. I actually remember Gosh, I can't believe how old I am now. I'll be 37 coming up here, and I'll get you in just a second. When I was a kid, I remember seeing in my astronomy books, I think I still have it. Yeah. This was an astronomy book I really liked when I was a little kid. And it said in here that Pluto is actually closer to the Sun than Neptune, and will be so until the year 1999. And I thought, wow, that's a long ways away. All right, Ellen, what were you going to say? No, because when we see Pluto, the orbit isn't perfectly in a flat line with Neptune. It kind of goes above and below. So, yes. So for this, again, this is the Kuiper Belt. Write down the first bullet point and then the first dash mark there. The folks at home want to see my old book. So just to give you a little size, just to give you a little interpretation about scale here between the solar system and the Kuiper Belt and the Oort cloud, the next slide is going to show you a little bit about how big those things are with respect to each other. So our solar system is right here. You can see it represented by those different colored circles. And if we scale that down, actually these are the inner planets. If you scale that down, you can see some of the bigger planets, and this is the orbit of Pluto and another place we're going to talk about called Eris, another little world. And this would be the Kuiper Belt. If we shrink that down, Oort cloud would be like way out there. So a little bit of an idea of scale. Again, the Oort cloud is not something that we've observed, though. So a comet is an icy body that periodically gets close enough to the sun to make a visible coma and tail. You can write that one down. So these comets, when they're not close to the sun, you would not see a coma or a tail on a comet when it's far away from the sun for two reasons. Number one, when it's farther away, it's traveling slower. And so that material isn't falling off of it. Part of what we see when we see a comet is the material being blasted off of it because it's going so fast. And number two, when these comets get close to the sun, it interacts with solar radiation coming off the sun, and that helps to blow even more material off of that comet. So without those two things, you're not going to see very much if you find a comet a long ways away from the sun. It's like Comet Halley right now is about as far away from Earth as it can be. And so if you were actually to go find that little piece of rock that makes up Halley's Comet, it would not look very spectacular. It's not moving fast, and it's not close enough for the sun for these things to become visible. So this is the structure of a comet. We've got 4 things to kind of take note of. It's got a hydrogen envelope on the outside. The tail extends very far backwards. Nucleus, that's the spot that actually has solid material, and the coma is the stuff that's surrounding that. You can kind of think of the coma as like the atmosphere of the comet. It's not actually solid, it's just a result of the solar wind and everything that's interacting with that icy body. So what I'd like you to write down from this slide is not these numbers, I just want you to know how big these 4 things are with respect to each other. You know, going bigger or going smaller. Know that the nucleus is the smallest, the coma is the next biggest, then hydrogen cloud, and the tail is the largest. So these are listed on this page from small to large.
You said you don't want the numbers?
I don't want the numbers. Just know the order. Smallest to largest, or largest to smallest, whatever. The only extra thing that I want you to write down with respect to the structure of a comet is next to the nucleus, write down dirty snowball. It's kind of the best way that you can describe the actual physical stuff that makes a comet up. Dirty ice ball would probably be closer, but just write down dirty snowball. You should know that. Anybody ever been in a snowball fight and someone throws that ice ball and it gets you in the ear or something? That sucks. So again, this is what's going on with these comets, the 4 different structures there. The other thing about comets is whether or not they actually speak to a young universe or an old, billions of years old one. Just like Earth, they speak to a world that is much younger than the Big Bang model and modern science suppose. Comets can't be old. They lose too much material each time they pass by the sun, and yet some of these comets we see are supposedly millions and billions of years old. It just doesn't work. So go ahead and write this slide down as well. That's going to be coming up, and that might actually be on the quiz. 2061. And I'll have you write that down later. You guys will be alive. I think I will be too. I plan on living to 100, I hope. I just hope I'm alive and able to see at that point. What'd you say? Oh, well. You probably will. Want to live to what in the Bible?
Like 600.
Well, you never know, Rob. So in the 1980s, that was the last time Halley's Comet came by. And it's easily the most recognizable name, and for good reason. In the past, this comet got close enough to Earth that it would take up a third or a half of the entire sky. It would have been quite the sight to see. So in the 1980s, everybody was excited for it to come back. It turned out, though, that it was very unspectacular. The reason for that is because, you know, Here's the sun. Here's Earth. And as Halley's Comet went around the sun, the Earth was in just the wrong location when it got closest. So ideally, you'd want Halley's Comet to fly by the sun and be like maybe here when the Earth is over there, but it wasn't. Halley's Comet flew by and it did like something like this. So we never really got a decent look at it, because when it's this far away from the sun, again, the coma isn't all that big, and it really dissipates quickly. So unless you're in just the right location, you're not going to see that great of a light show. But with Halley's Comet, it's at least possible. So in the 1980s, they actually sent something out that landed on Halley's Comet, and this is a picture that satellite took as it was approaching. So this is the actual physical nucleus of Halley's Comet. That's the material that actually makes it up. Another picture right here. Yeah. So this is essentially what you'd see right now if you were to stumble upon Halley's Comet in space. It would look like a big asteroid moving super fast away from the sun. Other pictures here. I believe this is of Halley's Comet. This was taken with a powerful telescope, though. It didn't look this cool with the naked eye. Another one there. And then there's this picture. This is Comet Hale-Bopp that we'll talk about in just a little bit. And you can see that we've got two tails here from this particular comet. And the reason we've got two tails from this comet is from the handout that I gave you. If you look on the side that has this slide on the top, it explains it right there. Basically what's going on is the brown stuff here. This is dust and dirt and pieces of ice from the comet flying off just because of the path it's taking and because it's moving so quickly. This blue tail is there because the sun is radiating solar wind and radiation in every single direction. So this blue tail will always be perpendicular to the sun. This brown tail is always going to kind of curve based on the direction that the comet's going. That's why it looks like it has two tails. You can think of the brown tail as like if you're going real fast through the wind, eventually you're going to lose things, and that's what that tail's from. And this is just from the sun shooting its radiation out. More stuff about those things. You get the idea. So yeah, this is Comet Hale-Bopp, and it was a really, really cool comet. It came by in 1997. I'm going to have you write a couple things down on this. This is a real picture. This is about how big it looked in the sky. It didn't cover up like a third of the sky or anything, but it was big enough to actually see. So write down Comet Hale-Bopp. Write down Great Comet of 1997 and Long Period Comet. Well, yeah, that's what we called it, based on the people that saw it first. Yeah.
I always thought pale was like fire.
Okay, no, it's just that the radiation from the sun would be the blue one, the brown one would be the actual material flying off of it because it's going so fast.
So is the shooting star and comet different?
Yes. I'll talk about shooting stars in a couple days. So this got a lot of publicity because it was, something like this hadn't been seen for years and years and years, and it hasn't been seen since. The one thing about comets is you never really know how good they're going to look until they get real close. Because we haven't been able to observe them so far away, it takes a long time to figure out mathematically where it's going to go and how big it's going to get. So, like this one, nobody really knew how amazing it would look until it actually got here. So it was kind of a surprise. It got a lot of publicity, but it probably did not get as much publicity as the cult that was associated with Comet Hale-Bopp. Generally, for every really interesting comet, there's a really interesting cult, and this is no exception. You can go ahead and write this down.
Which one do you want us to?
Just write the whole thing. I mean, at least they got a cool logo.
Yeah, but it's sad.
Yeah. It was very sad. The initiation video is actually on YouTube. I can show that a couple minutes if you want to see it.
The initiation video.
Yeah.
It's really so creepy.
The guy like never blinks.
All of them committed suicide?
Yeah.
It's in Johnstown. It's in Johnstown. All of them.
This one is
So yeah, what ended up happening with this is this group of people believed that there was a UFO following the comet, and what they thought was that the comet was going to rain down poison on the Earth, and the Earth everybody would die from all that poison, and only the people that committed suicide would be teleported to the spaceship behind it and then repopulate the Earth. Sounds legit, but it's awfully sad. The leader of the cult was bona fide nut job, obviously, but when some people, the poor people that were drawn to this guy were folks that are like lost in life, and your heart goes out to those people when you put your faith and your trust in somebody that you shouldn't. And this is an example of that. Very sad event.
Is there any evidence that UFO was? Like, did they have, like, I know there wasn't, but, like, is there any, like, evidence that there was?
There was like a picture was taken where there was like a speck that was behind it, and that's how they interpreted the speck.
It's like saying there's UFOs in
Right.
I mean,
there. That is honestly.
So again, there's Comet Hale-Bopp, and that's the path it took. These comets don't have to go in the plane of our solar system. Sometimes they come up from underneath and go back down. And one more close-up of it there. Now the one you've all been waiting for, Comet Halley. So for this slide, write down Comet Halley. Write down, I'll put a little arrow next to what you should write down. So Comet Hale-Bopp was a long period comet, and I forget what year that said it was coming back, 4,000 something. So that comet hadn't been around since about the time of Jesus, or a little bit earlier. Comet Halley, though, was a short period comet. comes back every 70-some years. What's 2061 minus 1986? 75? Every 75 years or so. So this visit in 1986 was not spectacular because it ended up being a lot closer or a lot further away from the Earth than ideal compared with Hale-Bopp or compared with when it visited in 1910. The Earth just wasn't in the same place in its orbit. But like with Comet Hale-Bopp, Comet Halley also had an interesting cult. You can go ahead and write this one down. Yeah. Sacred Followers cult attempted to sacrifice a virgin because that's just the best way to celebrate a comet. I don't know. You guys do it at your comet parties, but okay. And this is not an actual picture of that cult. This just popped up when I typed in cult in Google Images. I figured I should put a picture up there. So yeah, if you have comets, you're going to have cults. That's just the way the world works. You got to come up with a name and a logo, though. So this is a picture of what Halley's Comet looked like in 1986. This was taken from a telescope. It didn't look this spectacular in the sky. Hopefully it looks better when it comes back in 2061. That's the path it takes. It gets to roughly Pluto and then flies on back.
So it's on its way back now?
Yes. Yeah, it just turned around a few years ago, I think. So, can comets hit Earth? What do you think?
No.
Yeah, they can.
Yeah.
Might look something like that.
It's 2020, so...
One thing
There you go.
that you'll notice is
Don't
when
get the Earth anyway.
weird things impact the Earth, it always seems to happen in Russia. And this is no different.
I wonder why.
So there was a comet that hit in the Tunguska area in Siberia in Russia. A little bit of information about that. Write down Tunguska blast. From this slide, write down, obviously, the top two words, Tunguska blast, and then write down the last bullet point. Trees were scorched, devoid of branches, but standing upright. That's at ground zero, right below where the comet would have exploded. So yeah, comets range in different sizes. If they're not all that big like this one, they'll explode before hitting the Earth's surface. Because as you go further through Earth's atmosphere, it gets thicker and thicker, and it gets more and more difficult for that comet to stay together. This one would have exploded roughly 5 miles above the ground. This is artist rendition of what it might have looked like. No one really knows for sure, but it's kind of fun to look at pictures of what people think. Now, 1908, they did have cameras, so they did take some pictures of what it looked like in the area. These are just leveled, yep.
It said it was standing upright.
Well, the ones directly underneath were still upright. Further out from there, they were just leveled flat. And the area is recovering nicely these days, though, so that's good.
Oh, good for him.
Yeah. And that's the lake that was next to the impact, so it's looking good. A couple more images of comets, and then I'll see if we can bring up the see if we can bring up your initiation video into Heaven's Gate.
Yeah.
So a little quiz on comets coming at you tomorrow.